Hello class, I'm Jackson Allred, and today we're going to be working on the Exam 2 bonus questions. The question that we're going to be working on today comes from the Chapter 4, end of the chapter problems, number 5, which is write the balanced chemical equation write the net ionic equations then they want you to determine will a precipitate form, and if so, what will it be? Or what is the precipitate? Now for this one, number 5, we had to choose two. The first one that we picked was barium chloride and sodium sulfate. Forgive me for my bad spelling. All right, so number 1, barium chloride and sodium sulfate. Now, they want us to write the balanced chemical equation. So they've given us the two reactants, and we know they're both aqueous. So we're going to write just as they are, but we're going to make sure that we put our state, which is aqueous, plus SO4 aqueous. Now, we have to figure out our products here. So we know that when we have two metals and two nonmetals, the nonmetals swap between the two metals to form our products, which makes our products barium sulfate, which is just BaSO4, plus sodium chloride. Now, we have to determine the states of our products. We can do that with our solubility chart. So, if we take a look at our solubility chart here, we're looking for barium sulfate, and we are looking for barium sulfate and sodium chloride. So, as you can see in when it says the soluble ionic compounds, if you look up and you see Na, it says Na is soluble with all ions, no exceptions. So that means this is automatically aqueous. Now, barium, however, is not soluble with SO4 or sulfate. So that means we can rule that out, and it's the solid. Now that we've determined all of the states, we still need to balance the equation. So in order to balance the equation, we want to write out all of our elements here and determine how we need to balance them. So we have a Ba, we have a barium, a chlorine or chloride, a sodium, a sulfur, and an oxygen. So let me move the paper up for you. Now, on the reactant side, we have only one barium and two chlorines. We have two sodiums, one sulfur, and 4 oxygens. On the product side, we have 1 barium, we have 1 chlorine, we have 1 sodium, 1 sulfur, and 4 oxygens. So now we automatically can see that it doesn't take much to balance this one, that the only thing we need to do in order to make this balanced is to get Na and Cl on the product side to 2 and 2. So we have on the product side, in a compound, we have sodium chloride. So that just means we need to add a 2 to make it balanced. That gives us our balanced chemical equation. Now, we need to determine a net ionic equation right here. So in order to determine our net ionic equation, we have to take all of our aqueuses and split them apart, because that's what you can do when they're aqueous. You can't do that when they're solid, like barium sulfate here. So we're going to write it out, and it's Ba2 plus 2Cl negative plus N2Na, 2Na plus 1 because it's sodium, and then just write out SO4 2 negative, and that yields, and since barium sulfate is solid, you don't split it apart, so it just stays as it is. So it's just BaSO4 solid. But you do split apart sodium and chloride. So that gives you 2Na plus 1 plus 2Cl negative. So in order to find the total net ionic equation, you have to cancel out all of your things to make it the net ionic. So we have a 2Cl negative on this side, and we have a 2Cl negative on this side. Just like we have a 2Na on this side and a 2Na on this side. So that balances it out, and this is our net ionic equation. You get Ba2 plus SO4 2 negative yields barium sulfate. Now, the next question that we were asked is, will a precipitate form? We already answered that in the above question, and that is yes, because when you have the two aqueous solutions and they combine and make a solid or an insoluble solution, which means a precipitate, that would be yes. Barium sulfate is our precipitate. So is the precipitate. All right. With that being said, we are not finished because we had to do 2. The next one that we are going to do is calcium chloride and sodium phosphate, which is CaCl2 and Na3PO4. Now we need to write out our chemical equation. So we're given the two products, and we know they are aqueous. Next, we need to write out our products. So we just swap these, and that gives us Ca3 parentheses PO4 2. It's a 2 on this side because calcium is a +2 charge, whereas this one was just a +1 charge. That's why you do the parentheses. We still don't know what state it is, so we don't. So until we look at our solubility chart. The next product that is formed is sodium chloride again. Now, if you remember from last time when we were looking at the solubility chart, we know that sodium combined with any is always going to be aqueous. So that is already aqueous. Now, on this side, we have calcium and phosphate. Now, if you look at the insoluble ionics, it says that they are insoluble except for when paired with a group 1 cation. And we know that calcium is not in the group 1 cations, so that means this is going to be a solid. All right, now that we have determined our states, we still need to balance the chemical equation. So we're going to write it out, and it's Ca, Cl, Na, P, O. Now we got to determine on each side to balance it. We're going to determine what we need to balance. So there's 1 Ca on this side, there's 2 Cls, there's 3 Nas, there's 1 P, and 4 Os. Now, on this side, we have 3 Cas, we have 1 Cl, we have 1 Na, we have 2 Ps, because this gets times by that to make it 2, and then O's we have 8. So, in order to balance this, we're going to need to first multiply our calciums to get them to 3. So when we do that, that turns this into 3 calciums, but we also just multiplied our Cls, making that turn these into 6. So we have to balance out, we have to get our chlorines to 6 too, but we also have to balance out our sodiums as well. So we can just times our chlorines, or chlorides, and our sodiums by 6. And that's going to give 6 NaCl. Now, our phosphates are still unbalanced. 1 and 4, 2 and 8. So basically, if we times both of these by 2, it'll make it balanced out. So if we times this by 2 and this by 2, it'll give us 2 and 8. And when we times this by 2, that times sodium as well by 2, which gives us 6. That balances our equation. So your coefficients that you should wind up with is 3, 2, 1 on this, and 6 on NaCl. So that's your balanced chemical equation. Now we need to do our net ionic equation. And that is, since they're aqueous, we split them apart. You have 3Ca2 plus 6Cl negative, plus 6Na plus 1 plus 2PO4 3 negative yields, and since calcium phosphate is solid, it does not split apart, so it stays the same. Okay, and then we have to split apart our Na and Cl, so that's 6 Na plus 1 and 6 Cl negative. So just like before, we got to cancel out the ones on each side to determine our net ionic. So we cancel out 6Cl because that's on both sides, and we can cancel out 6Na because that's on both sides as well, which gives us 3Ca2 plus plus 2PO4 3 negative gives us to yield solid calcium phosphate. Solid. Now, when it asked us, will a precipitate form? We can say yes, because the two aqueous solutions formed a solid. So the precipitate that was formed is calcium phosphate. And that'll be all for today. Thank you.